Hey everyone, I'm going to take a look at doing a couple examples from Worksheet 2.5. We call it the Big Problem Worksheet, where we pull everything that we've learned from the sections prior, including 2.5, into one worksheet. So using everything that we know to kind of talk about a polynomial in depth. So I'm doing example number 2. So here's my polynomial, 2x to the fourth minus x to the third minus 7x squared plus 3x plus 3. First of all, maximum number of roots. So the maximum number of the roots is always the degree of the polynomial. So since this is an x to the fourth, the degree is 4. That means there's at most 4 roots. And then it says list all possible rational roots. So if you remember, you take the factors of the constant divided by the factors of the leading coefficient. So the factors of 3 are 1 and 3. The factors of 2 are plus or minus 1 and plus or minus 2. And then we just divide them all. So you've got positive and negative 1 divided by positive and negative 1, which would be positive and negative 1. And then we do positive and negative 1 over 2. That'd be plus or minus 1/2. Positive and negative 3 divided by 1, positive and negative 3, and positive and negative 3 divided by positive negative 2 would be plus or minus 3/2. So those are all your possible rational roots. Then we're going to be looking at my PNC chart. So total number, your positive roots, negative roots, complex roots, and total. So PNCT chart. So remember, the first thing we look at is the polynomial, and we're looking at sign changes. So we start positive, then we go to negative, then we stay negative, then we go to positive, and then we stay positive. So on this one, we've got 2 sign changes. So my possible positives are 2, and then remember we subtract 2 from that, which would be 0. If I subtract 2, I get into negative, so I don't do that. Can't have a negative number of roots. And then remember, we have to take our function and replace x with negative x. So if I take negative x to the 4th power, that's going to stay positive. Times 2 is 2x to the 4th. Then I have, don't look at this negative right now. If I replace x with negative x and cube it, that'll be a negative x cubed. Times this negative would become positive x to the 3rd. X here, if I replace this x with negative x and square it, that becomes positive, but times a negative would be negative 7x squared. Replace this with a negative times a positive would be negative 3x, and then plus 3. So then we look at sign changes here. So I start positive, stay positive, drop negative, stay negative, go positive as I move along. So again, 2 sign changes, so possible negatives are 2, 0. So then I do my chart. Positive, negative, complex. Remember, complex are your imaginaries, and total. So we've got a possible 2 positive with 2 negative, and I have a total of 4 total roots. So this already adds up to 2, so that means there'd be no complex. Then we'll look at 2 positives, 0 negatives. Again, total of 4. That means there has to be 2 positives. Now we'll look at 0 positive, 2 negative, total of 4. That means 2 complex. And then 0 positive, 0 negative, and a total of 4, which means 4 complex. So those are all my choices. Upper bound and lower bound we're going to talk about at the very end. It's not until I have this thing totally graphed can I find my upper and lower bound, and I'll explain to you what that means. y-intercept. Remember, the y-intercept is when x is 0. So if I come to my function at the top and I replace all my x's with 0, my y-intercept is going to be 3 because of my constant. So 0, 3. All right, so now it says determine the actual rational roots. Of these up here, which one are actually roots? So that's when I go to my calculator. So it's really important. You have your graphing calculator or some calculator that you can, your TI or Desmos, you can use that. Type in my function, so 2x to the 4th minus x to the 3rd minus 7x squared plus 3x plus 3. Make sure you're putting in your original function, not the one where we change the x to negative x. Okay, I think that's good. I'm going to hit graph. All right, so there are actually 4 roots here. So looking at what our possible rational roots are and what I have here, I might zoom in and see if I can see things better. Zoom in. All right, so it looks like this is negative 1/2, and that was a possible rational root. So negative 1/2, and definitely 1 right here. So that's my other one. And then it says use the intermediate value theorem to find the intervals 1 unit length apart in which the polynomial is guaranteed to have a 0. Well, if we look over here, you can see how there's a 0 between -2 and -1. And we already know about this one, so I don't think we have to put that. If you want to, you can. So there is one between -1 and 0. There's one at 1. That's actually an integer. And then there's one between 1 and 2. And then down here it says show synthetic division to break the polynomial down. Well, I know these are my rational roots. I need to find the other two, the one between -2 and 1 and between 1 and 2. I need to find that root and that root. So since I know these are roots, I'm going to use synthetic division. So I'm going to put my -1/2, because that's my x value, in the little box. And then again, I'm going to take the coefficients of the original polynomial and put that across here. So that is 2, -1, -7, 3, and 3. And then I'll leave my space, drop my 2 down. And then I'll do -1/2 times 2 is -1. These get added, so that's -2. -1/2 times -2 is +1. These get added, -6. -1/2 times -6 is +3, which is 6. And -1/2 times 6 is -3. And I add those, that's 0. So that tells me that is an actual 0. We thought it was, but yeah, that guarantees it. Now I'm going to continue with my synthetic division. So remember, at this point, I've got an x to the 3rd function because I started with an x to the 4th. So now I'm going to put my 1 in the box. I'm going to start where I left off. The 2 gets brought down. So 1 times 2 is 2. Add these together is 0. 1 times 0 is 6. -6 times 6, I'm sorry, -1 times 0 is 0. Add these together, -6. 1 times -6 is -6. Add these together is 0. So again, that proves that 1 is a 0. So I'm left with this. This is equivalent to 2x squared, there's no x to the first, minus 6 equals 0. So I'm going to find my other 2 roots by this quadratic. So I'll add 6. divide by 2, and take the square root. So my other two are plus or minus radical 3. And then it says, write the polynomial equation as a product of linear factors, irrationals in radical form. So that means these, they want me to leave them as radical form. So I'm going to have p of x. It's an equation. So I know this is a factor. This is a root, negative 1/2. The factor 2x plus 1 is the factor that gives me that value for x. 1 would be x minus 1, because if I set that equal to 0 and solve for x, I get 1. Same thing here. If I set this equal to 0 and solve for x, I get negative 1/2. Here I would have x minus radical 3. That's for the positive radical 3 solution, and x plus radical 3 gives me the negative. So now I have a polynomial in factored form. I do not have to multiply this out. I just want to keep it in factored form. All right, so now let's go to our graph and plot what we know. So we know there's a 0 at negative 1/2. We know there's a 0 at 1. We know there's a 0 at positive and negative radical 3, which is about 1.7, negative 1.7 and positive 1.7. We know our end behavior because we have a degree that's even and a positive coefficient. That means my end behavior is increasing, increasing. And we went ahead, I mean, we graphed this. So I'm going to go back to Zoom 6 and take a look. Again, we know my y-intercept is 0, 3. And you can do this one of two ways. This is kind of an estimate. If you want to go to your table and you can want to plot some other points and you want points in between, you can do that way. Or remember, we can find these low points. So we want to go to minimum, and I want to find what this low point is. So I'm going to go to the left of that minimum, and I'm going to go right of that minimum, enter, enter. And that's negative 1.25, negative 4.8. So negative 1.5, 4.8. Again, this is an estimate, just to kind of give me a general shape of my parabola. And then I want to see what this low point is over here. So I'm going to do the same thing again. So second trace, minimum. So I'm going to get over here. Left of that minimum would be here. Right of that minimum, here, enter, enter. 1.4, negative 1.58. So negative 1.4, 1.58. All right, so my final thing to talk about is my upper bound and my lower bound. Okay, upper bound. I want you to put your pencil on the last 0. My last 0 is right here at radical 3. An upper bound is the integer to the right of the last 0. So an integer are whole numbers. So the integer to the right of that would be 2. So my upper bound would be 2. If I had an actual 0 on 2, I'm still going to go to the integer to the right, which then my upper bound would be 3. So it's important. If it's on an integer, it's the one to the right. A lower bound, same thing. I take my very last integer going to the left, so at negative radical 3, and it's going to be the integer to the left of that, the lower, further left. So that would be negative 2. That's my lower bound. So that is how you graph a polynomial completely based on all of this information that we've learned so far in Chapter 2.